All right, so looking at a few things out of chapter two. First thing is the distribution of data and their shapes. So the first one is our bell-shaped curve. It is symmetric about the mean. The mean would be in the middle, and everything to the right of the mean will reflect in the same fashion as to the everything that's in the to the left of the mean. 50% of your data will be to the right of it. 50% of your data will be to the left of it. We'll talk more about all of those details later. But this is the one, excuse me, this is the one that you most definitely want to hold on to because it will continue to come up as we progress throughout the course. Those the bulk of our data is right here in the middle, and then it begins to disperse when you go away from the mean. This is considered your normal distribution. Normal distribution. All right. And I don't know if I mentioned it last class, probably didn't. Don't forget, most of you have your cameras. Well, do not have your cameras enabled, and that's fine, especially for the lectures. But remember, I cannot see you, cannot see if you're writing, or cannot see if you're confused or anything like that. So if there's any a time where I scroll up, but you need me to pull back down, or or you need me to re-explain something, or moving too fast, anything, make sure you say something. Make sure you unmute. Once again, I can't see you, see if you're still writing or anything like that. So I wouldn't know. I wouldn't know. So just let me know, and then I will go back down or scroll back up accordingly. All right. So another one is uniform distribution. We just have the same level of distribution. Looks more like a block. All right. And the next two are the real reasons for me to bring this up because that's where people sometimes had confusion about in the past. When you're talking about your data being skewed left, to me, in my mind, it even sounds like that means your data will be pushed to the left. But in actuality, the tail of your data is going to be to the left, and the bulk of your data is actually pushed to the right. So the main thing that you're talking about when you're saying skewed left, that means the tail of your data is to the left. That means the least amount of your data is actually to the left, and the bulk of your data is to the right. And then in the same way, you're looking at skewed right, the tail of your data is going to be to the right, and the bulk of your data is to the left. All right. Questions on either one of those four? All right. So next thing, your stem leaf plot. Your leaf is going to be the rightmost digit of a data value. Your stem will be all of the values that precede that rightmost digit. All right. So two examples of that. If I had number 53, the 3 would be the leaf and the stem would be 5. If I had 127, the leaf would be 7 and the stem would be 12. So once again, your leaf is going to be the rightmost digit. It's always going to be a single digit. Your leaf will always be a single digit. And then your stem will be everything before that single digit, that leaf. right, so let's do an example. All right, so here's our data set. 41, 50, 56, 71, 72, 72, 75, 80, 80, 82, 83, 84, 88, 88, 89, 91, 92, 93, 100, 101, 101, and 112. So when you look at what we have here, we have our smallest value to be 41, largest value to be 112. So we're just saying that this data set goes from the 40s to the 110s.
Are we supposed to be making a stem leaf plot?
No, I was giving people a chance to copy it.
Oh.
Yep. Didn't want to move too fast. So I'm about to show you how to create that now. All right, so this is how you would set up your stem leaf plot. Remember I mentioned that we're going from the 40s to the 110s. So you set it up this way, going from 4 and going to 11. Because remember your leaf is that last digit. So everything before that is your stem. So we're going from the 40s to the 110s. All right, so each leaf that we see, we're going to write. So we have 41. So 1 would go right here in the 40s column. And there's only 41 that's in the 40s. So that's the only one we would write. Now 50, we have 50 and 56. So that would be 0 and 6. And then you keep on with that same thought process. So notice there are no 60s. What I would not do is write a 0 here because that represents the number 60. You would just leave it blank and then go to the next one. So there's 71, 72, 72 shows up twice. I believe that was 75. Then we have 80 twice, 82, 3, 4, 8, 8, 9. Yeah. Then 91, 92, 93.
Can they put commas by it
Nope, you
or
wouldn't put commas. Nope.
no? Okay.
100. 101, and then 112. So that's how you would do it. So I know you may be asking, well, when would you use this or why would you use it versus using anything else? Because really all it is a bar graph, you know, another form of a bar graph. You know, so basically you would use it to, if you had an audience, you know, if you did research on your audience and you wanted to appeal to your audience because they like numbers, you're dealing with a number field audience or scientific audience with scientific background. There you go. Colors and pictures may appeal more to an audience that has the background of being, well, it's the arts or you know, or art type mind, or you just know that colors and pictures would appeal to that audience, then you would use the bar graph and make them be different colors. So it's really all about appealing to your audience and keeping your audience interested in what it is that you're talking about. Also, when you talk about statistics, you will learn that you know, statement numbers never lie, but they can mislead. And so what I mean by that is that you could take the numbers that you have and use them a certain way to say the exact opposite of what someone else has said. That's why you don't really get caught up, if you really know statistics, you really don't get caught up with political figures or political numbers or anything like that, because you could say that this president did this, but you can also say the complete opposite with those same numbers if you know how to use them properly. Just like when we get into it, we use outliers, and you'll see that in in your definitions, outliers are extreme values, whether large or great. So if you run an experiment and you experience outliers, excuse me, they said I'll run the outliers or run your numbers with outliers and then run it without. and whichever one fits your argument best, that's the one you use. Well, if someone were to ask you, well, didn't you have outliers? You can say, yeah, I don't know what's wrong with my voice. I think I need some water. So, if they ask for outliers and you say, yeah, I had them, you say, well, why didn't you use them? And you would say, well, they were outliers and they're not normal. But if you do use outliers and they ask you, why did you use them? You say, well, those are my um, outcomes. So that's why I use them. So really, statistics is about, hold on one second. Hey, y'all, I don't know what's going on with my voice. Then that means it's time to go. So yeah, outliers are basically options on using them. And really, that's what statistics are about, using numbers in order to be able to prove your case. Any questions? Damn, I'm losing my voice. Any questions? Any questions? And that's going to be recorded. Anyway, I got a better recorder from my last class, so y'all will be all right. Any questions? Any questions on anything? So with that being said, yeah, that was it. So make sure you get into my math lab. Make sure you do your homework. You have chapter 1 and chapter 2 homework that's available in my math lab. We have chapter 1, chapter 2 definitions. Let's see what else. What else? Don't forget Monday is Martin Luther King's birthday. So if you have a Monday class, that doesn't affect this class. But if you have a Monday class, you shouldn't be having class on Monday. What else? What else? What else? I think that is it for right now. Next class, we will be getting into chapter 3. That's where our calculation first starts. Real calculation starts in chapter 3. Let me see anything else. Oh, don't forget to, like I said, get into my math lab. Don't forget the attendance is solidified through my math lab. Um, the government is really cracking down on attendance because a lot of people are getting this free money and then they're not going to class. So they're really cracking down on us to make sure we report that. So make sure you guys are showing some type of level of attendance so I can ensure that I have something to report on your behalf. Um, going into my math lab, just like I said, solidifies that. All right. So with that being said, questions, concerns, or comments before we close out. Once again, chapter 1 and chapter 2, best thought process when it comes to that is to most definitely be done with that, going into February. January 31st is a Sunday. That's a good marker to say, hey, by January 31st, I don't want to have nothing else left from chapter 1 and chapter 2. All right, I see 2 people raise their hand. Let me see, it's not letting me. So yeah, just unmute.
For the definitions, do you want us to just write it and then take a picture and send it, or would you rather have it typed?
Either way is fine. Doesn't even matter. Whichever one fits you best.
Okay, thank you.
Not a problem. Ms. Bethea?
Oh, um, Mariah. I was asking about the attendance. So you just go into my math lab and then, it sees that you've been there. So I guess you take that for attendance.
When you
Okay.
go into my math lab, go into at least one of your homework assignments, then hit save, just to, it'll say that you were in there. So
Okay.
don't just log on, but you have to at least, to my understanding, you have to at least go into a homework assignment and
Right.
then, save it and then come on out.
Okay. Okay. Thank you.
All right. Did I see another hand?
So these lectures are being recorded, right? They'll
Yes.
be
Yep. They're recorded right now. And then what'll happen is I'll convert it and then send it to YouTube and then send you guys the YouTube link.
all right. Perfect. Thank you.
Yeah. Yeah, this one is all right until I start coughing. So, yeah, I don't know what that was. All right. Anything else? Anybody else? Pretty good. Straight. All right. So, never hesitate to ask a question if you have any issues. over the weekend, you want to send me an email, feel free to do that. You can email me, vtucker@tcc.edu, or you can shoot me a message through Canvas. I will still get it in that same way as an email and respond the same way. Yep, that's pretty much it. If you have any questions about chapter 1 or 2, you know, even coming into next class, and you have something you want to ask, feel free to ask it before we jump into chapter 3, and we'll still be good to go. Outside of that, if you don't have anything else, you guys have a great weekend. Be safe, and I will see you on Tuesday.
Thank you. See you later.
Thank you. Take care.
Have a good weekend.
Thanks. You do the same, man. Take care.